Ciao friends! Today I want to spend time trying to do extreme optimization in Vertipack. Vertipack is the engine that runs the tabular model for analysis services and Power BI Desktop, and I will show you what you can do using two settings, which are the encoding hints and the available in MDX setting. Now, what I'm going to show can be used in production for analysis services and Power BI the service using XMLA endpoint. However, I will show you all the demos using Power BI Desktop, but in order to do that, I had to enable an unsupported feature because what I'm going to do is not supported for Power BI Desktop, but is supported for the models that you publish on the service or on Azure Analysis Services or on Analysis Services on premises. I will use Power BI Desktop just because it's easier to test and to see the differences. I will also use a tabular editor and DAX Studio. And finally, usually this is an unplugged video where we don't do any edit, but because I have to refresh the model and a table that is particularly large several times, I will probably squeeze that time so that you don't have to wait a few minutes every time I refresh the model. Ready? Let's start. I prepared a demo here, which is Power BI Desktop file with a Contoso model, which has the classical star schema. We focus on the sales table that has 12 million rows. So far, so good. You have seen other videos with the same model. So let's take a look at how the table sales is consuming my memory. So if I go here, Advanced View Matrix, I'm gonna see in DAX Studio how Vertipack Analyzer shows the information about the model. So let's start from the summary. The summary shows that the model has 750 megabytes, which is a lot. And the classical and simple optimization is to remove the columns we don't need, which in this model are the online sales key, the order line number, and the order number. So you see that these three columns here can be removed, and we will save a considerable amount of memory. So we have 200 and something megabytes. So let's do that. I can just go to Power BI Desktop. I can go here and I can say, okay, I want to get rid of this column, order line number, order number, and I hope that I don't break everything here. I don't know why it is not updating this. This is funny. So, and let's go online sales key. Delete from model. Here we go. Now, once I do that, hoping that the data is refreshed here. So let's go back to DAX Studio and let's try to refresh the view matrix and let's see what happened. So you see that we reduced the size of the model. So we have only 540 megabytes, which is not only, it's a lot of memory, but we got rid of the columns we didn't use before. So now we can focus on why we are spending so much memory. And you see that we have two columns, unit price and net price, that have a lot of memory. You see these column sides here. And the reason for that is that they have a lot of unique values stored. Now, the best optimization would be reducing the cardinality, but let's assume we cannot. Let's assume that this is some metric about how we store numbers about the revenue. So we don't want to lose money. We don't want to lose information for the accounting. So let's assume that we cannot round the number to the closest integer, for example, which would be the easiest way to reduce this. So now we can spend our time looking at why we have so much sides in memory. So this sides is made by data, dictionary, and hierarchy sides. So let's start from the dictionary. You see that the data volume, so I take for granted that you know how the Vertipack engine works. And this is explained in other videos, is explained on our Optimizing DAX video course. It's part of the Vertipack engine. We also have a book about that, an entire chapter discussing that. So I have to take for granted you understand the difference between data, dictionary, and hierarchy sides. And I noticed that the dictionary is bigger than the data sides, which which is expected, but because I have so many unique values as cardinality, the dictionary is going to be big. Now, these columns contain just numbers, and the Vertipack engine made a decision to use the dictionary. I could try to see whether if I try to suggest to the Vertipack engine, look, these are numbers, you could try to skip the dictionary. Usually the Vertipack engine makes the right decision. Maybe it didn't make the right decision this time. So let's try to see what we can do. So now I open tabular editor. So I go here in, sorry, not here. I go in Power BI Desktop. I go here and I open the tabular editor connected to this model. And here, if I read down in tables, sales, remember we're looking at two columns. Let's just make sure we do the right thing. So we go here and we go here. So we have unit price and net price are the columns that I want to examine. And so I go here, so let me remove my face so we can see better. Net price has these settings, and unit price has these settings. So what I want to focus here, so now I can move this here so I can show my face again. And let's take a look at the two information I want to discuss. The first one is the value encoding. But as you see, I don't have all the properties here that if you use the tabular editor or Visual Studio with models that you publish on analysis services, you know that there are many more settings here. But by default, when you connect tabular editor to Power BI Desktop, it doesn't show all the properties because they are not supported. You cannot change them in a safe way. So now we do this, we go in preferences and we change a setting. Let's see, where is the setting here? Come on, okay. So let's, sorry, I try to do this on another window. Here we go. So this is the setting window. And the setting I want to change is this one. Allow unsupported Power BI features experimental. So when I enable that, I'm saying to tabular editor, look, I want to see all the metrics, all the properties. And you see here that now I have this, when I select here unit price, I have these options that were not available before. Now, once you set this setting as true, I show you another thing. If I go back to Power BI Desktop and I open Tabular Editor again, you see that we have this dialog box, this warning, when you edit the Power BI model using Tabular Editor with this setting enabled, this warning is telling you, look, you are using the experimental feature, you have access to properties that are not supported if you change them for a Power BI Desktop model. As I said, this is not supported, but for what I want to do, I will probably do something that is relatively safe, or at least will not crash the demo, let's say that. And I want to discuss now about a few options we have here. So now we have, let's just reduce this to a size that we can examine. So now I think this is visible in the screen. And if I go to the options here, I have two settings. And the first one is the encoding hint, this one. The encoding hint that we see here is set to default. Default means that we ask to the Vertipack engine to make the right decision, basically. Now, we know that the engine chose the dictionary which corresponds to this setting. So if I use as encoding hint hash, I would suggest, look, try to use the dictionary as the best way to compress this column. We want to do the opposite. We want to ignore the dictionary and try to do the compression using the value encoding of the Vertipack engine. I apply the same setting here, and I do this only on these two columns because I know that in these two columns, the dictionary is particularly expensive, because otherwise usually I trust the Vertipack engine. I just want to do this for the purpose of this demo. So now I modify these settings and I save this. Now, nothing happened now because this setting only applied to the next refresh data operation, which is what I do now. I go here, let's go in the table window, and I go in sales, I right click, and I refresh the data of the sales table. in a few seconds for you, minutes for me, this will be ready to use. Okay, now the data has been compressed with the new settings, and we can go back to DAX Studio that I opened here. This is the previous setting for the compression. You see that we had this total here, 560 megabytes in total for the entire table, and 260, 217 megabytes for each of the two columns. Remember, only we have 45, 41 megabytes for the data of these two columns. Now, when I refresh this, when I click on View Matrix again, I will read the new settings. So let's take a look at what changes when I do that. So I open this, and I notice that the dictionary is still here. So actually, my value encoding didn't have any effect, and I have still the same situation. Why that? Because the problem is that I tried to use this for the double data type. So actually, I should have tried to modify the data type of the column before, because with this data type, usually my encoding hint could be ignored. I mean, it's not certainly sure, but the way the encoding type is evaluated is a little bit different when you have a decimal or fixed decimal. So the decimal number, which is the floating point we have now, is actually enforcing the engine to use this technique. So let's try to do this. So let's go to the net price here, the net price column, and you see that this is stored using decimal number, which is a floating point. So now we can try to use this as a fixed decimal number. And again, I will squeeze the video because it takes a few minutes, because as soon as I click this, it will try to compress the data. It didn't take too much, but I do the same for the unit price, because unit price has the same problem here. So now I set this to a fixed decimal number. Okay, now I can go back to DAX Studio and see what happened now. So I click on View Matrix again, and now you see that because I re-encoded the two columns where I changed the data type, and I also had the constraint to use the value encoding, I have this situation. This situation shows that I reduced a lot the compression of these two columns. Now, sometime using the fixed decimal number would have been enough. But as you see, one explanation why we actually reduced the compression, improve the compression, reducing the memory, is because we reduced the number of unique values. Why this happened? The reason is that it's true that we had a larger number of unique values, but remember, we were using a floating point. And so probably I had different numbers because of different imprecision that were not relevant for my numbers. I'm actually storing in a fixed decimal number 4 digits after the decimal point, which is more than enough for the values in US dollar I want to store. So whatever is after that is just noise I want to ignore. So I could have done this rounding in the data source, but again, when you use a floating point calculation like I had in my views, it could be hard to do. So I could cast the data type, or just choose the data type. Nevertheless, when I have as data type a fixed decimal number, I could still have the dictionary chosen as a way to compress the data, because sometimes the engine could be not correct, so could not make the right choice, because it depends on the way the algorithm works. But long story short, if I notice that I have a dictionary that exists in a table that has a very large number of unique values, I could try to use the encoding hint to reduce the dictionary to 0. This actually increased the data. If you remember, it was around 40 megabits, now it's 50, but because the table is not too large compared to the cardinality of the columns, actually it's a benefit to use this type of encoding. But can I do more? Can I do something more? Well, if I analyze the data, I see that I still have an hierarchy size here, which is consuming for 24 megabytes, which is still more than 10% of the size of the table. In certain conditions, it could be much more. And if I extend this analysis to the entire table, actually, it could be, I could have other columns with a large consumption. Now, I want to make the demo relatively easy, and I want to show you what can I do and what is the side effect of doing something that will affect the hierarchy size. So I can go again in tabular editor, and I can say, okay, here I want to change the setting here available in MDX to false here. So I changed this to false. Let me just move this here so it's easier to read, and also this one. Now I can increase the size. So you see that I chose available in MDX to false for unit price, and I do the same for the net price. Here we go. When I do that, and I could actually do this for all the columns of the sales table if you want. But now let's do this only for these two columns. Again, I save this. Nothing happens immediately unless I refresh the table sales again. And again, I will squeeze the video now to wait just a few seconds for you. Okay, now we are ready to see the result of that. So we go back to DAX Studio and we refresh the view matrix again. Remember, we had the table size at 200 megabytes now, and we had 24 megabytes for the hierarchy size. I click view matrix and I see that I saved other 20 megabytes in the table size, and I reduced to 0 the hierarchy size for net price and unit price. So this is a further increase in compression. However, we have side effects. Everything we do could have some side effect. There was a reason why we had a hierarchy size there. So let me show you what we lost by doing this change. So if I go back to the visualization here, you see that all the columns here are visible, which means that if I open this model in Excel, I have these columns visible too. Now, let me show you this. So if I go to sales, you see in this area, so let me remove my video here. So you see that we have in this list here, we have date, we have sales at a certain point with all the columns that we have in the sales table. Now you see that we have all the columns here, but we don't have anymore the columns unit price and the column net price. So the columns as individual columns are no longer visible in Excel. And this means that we cannot use the columns in a filter. Imagine you want to apply a filter saying, I want to filter the unit price greater than $100. In Excel, you can no longer do that because we removed the visibility of those columns from MDX, and Excel talked with MDX to the tabular model. Whereas in the Power BI desktop report, I still have unit price here. I could apply unit price, and I could apply a filter here saying, oh, I want to say that this has to be greater than 100. Oops, something happened here. Okay. Greater than 100, I click it on function. And I apply this filter, and this filter is applied, and my report is refreshed. Now, there is a small price to pay in Power BI 2, because the lack of these additional structures slow down the filters applied in DAX over those columns, especially a filter like that. But it still works. So it's just something, if you say, I almost never use this column as a filter, it doesn't matter. However, both Excel and Power BI can still use the column that is not visible in MDX within a DAX measure. So if I have a measure that is using the net price, it's still working. let's take a look. We have a measure here called sales amount. Let's go to the demo. You see that the sales amount measure here is using sales net price. And if I go back to Excel, the sales amount measure is visible here and can be used in my pivot table without any problem. And of course, I can browse the data by continent and country and so on. And it just works. I didn't lose anything in performance when I aggregate the column that is no longer visible to Excel. But the idea is that I have an effect. So if I remove the setting from all the columns, what can I get? I could save other 240 kilobytes, but I will remove these columns to be visible in Excel, which could be a good idea because these columns, usually the columns in a fact table should be made invisible to the user to both Power BI and Excel. And so probably I don't spend too much time. But remember, if you have a condition in your measures where you apply filters that can be applied using the sort order of the column, you will lose something in performance when you remove the MDX, the visibility in MDX. So let's just go back to the properties in Tabular Editor because I want to remind you, we have seen the effect of this setting available in MDX and encoding hint in the compression of your data. The final result I obtained is that my model that was initially 750 megabytes is now just 177 megabytes. And of course, this could be very different in your model. You have to try the techniques that I've shown you because, of course, I cannot share the large database I have here. It would not be much value to provide you a sample file in this case. My suggestion, you can use the technique that we have seen to make your test on a separate copy of your data in Power BI Desktop, because remember, I've shown you something that is not supported. So because of that, you could break your Power BI Desktop file. So do this in a copy of your data, just as a way to see whether you could get some improvement in the compression of the data that you can apply to the model you publish on Power BI service or on analysis services using, for example, a tabular editor through the XMLA endpoint. I hope you enjoyed this session. Remember, you can see how the Vertipack engine works in other videos in our book, The Definitive Guide to DAX. We have an entire chapter and we have an entire video course about optimizing DAX, where we explain more in detail why these settings have this behavior. Enjoy DAX.